Assalamualaikum warahmatullahi wabarakatuh and good morning. So today we will continue our previous lecture on DFT, finding the DFT by using the properties. So last week we have covered the properties of shift, okay? Number 1, number 2, and also the folding properties, number 3. So we will continue the example B4, how to find the DFT, discrete Fourier transform, by using the properties. So this fourth question is to find the Pn equals to x conjugate, the conjugate value of xn, discrete signal. So in this question, there is no properties in the table. So this is the properties that you need to memorize. Pn equals to x conjugate n. To calculate the PDFTK, we need to find the conjugate of folding value of xDFT. So conjugate xn, since our value is already a real value, so the discrete signal of Pn will be the same as xn, which is 1, 2, 1, 0. And then for the PDFTK, since our value is the same as the xn, so our DFT will be the same, which is 4, negative G2, 0, G2. Okay, next the question is on the product property. So we need to find the Hn equals to xn multiplied with xn. So this is not the convolution, but instead this is the multiplication of the discrete signal xn with the same signal xn. So to calculate the multiplication, we just multiply each of the discrete signal at the same n. For example, x0 multiply with x0, and then x1 multiply with x1 until until n equals to 3, which is x3 multiplied with x3. And the discrete signal, in our case, xn is equal to 1, 2, 1, 0. So we just multiply with the same signal, and we will get 1, 4, 1, 0. And how about the DFT? How we can find the DFT? So we need to refer to the properties table of DFT, since we need to find the value of product xn with xn. So for the yn here, we will change to xn. So this ydftk is changed to xdftk. This is the equation to find the DFT value of HDFTK. So this is the symbol of periodic convolution. So how we can find the value of periodic convolution is like this one. There are a few methods. In my case, I use the sum by column for the periodic signal, and you can try the cyclic method also, and we will get the same answer. So this is the sum by column, you can try. Okay, and then we have we need to divide into two parts to add the first half with the second part here. So 16 negative J16 negative 4 J16, and then this is the second part, 8 0 negative 4 0, and then we add these two value, and we will get 24 negative J16 negative 8 and J16. And please remember, we need to divide by the number of sample, which is 4, and the final answer will be 6 negative J4 negative 2 J4. So next question is how we can calculate the periodic convolution. Cn equals to xn, periodic convolution with the same signal xn. So first we need to find the discrete signal Cn, and using the periodic convolution, for example cyclic and sum by column. Okay, so I use time by column to calculate the periodic signal for the discrete signal Xn, and the same technique that I've shown to you. Okay, and you will get 2464. Please do the revision on the convolution, periodic convolution, so that you can solve this this question of periodic convolution discrete signal Xn with Xn. Next is how we can find the DFT of the Cn or CDFTK. So first you need to find this equation, these properties, Xn periodic convolution with Xn. So this one is in the table, Xn periodic convolution with Yn. Since our question is Xn, so we can change the YDFTK here into XDFTK. So this is just a name, so you can change depending on your question. Okay, so for DFT it is easy, since we just need to calculate the multiplication of XDFTK with the XDFTK. So to calculate the XDFTK with XDFTK, we just need to multiply the DFT at the same K. So for example, XDFT K equals to 0 with the XDFT 0, XDFT1 with multiply with XDFT1, XDFT2 multiply with XDFT2, and lastly XDFT3 multiply with XDFT3. So 4 times 4 is 16, negative J2 multiply with J2. So negative, it will cancel out. J to the power of 2 is negative 1. 2 times 2 is 4. So we will get negative 4. 0 times 0 is 0. J times J is negative 1. So we will get negative 4. So this is the CDFTK signal. Okay, next is the question regarding the regular convolution. Okay, so for the regular convolution, Sn equals to the convolution of the Xn with Xn. Alright, so for the convolution we need to use the appropriate method, which is you can use the sum by column method, the polynomial sliding strip. Okay, so you can choose your method. In my case, I just use the sum by column method. Okay, and this is the answer for the convolution. We have 1464100. Okay, how can we find the DFT signal? So to find the DFT signal, we just change the value of discrete signal. We have 1464100. So you can use your calculator to find this value. So for the regular convolution, again, it is not in the table. So we need to find it by using the definition one by one for k equals to 0 until k equals to 6. Okay, this is how we can calculate by using the option button in the calculator. Okay, for this slide, I have shared with you how we can calculate the exponential value by using the calculator. So as we can see here, the mode for our calculator is in radian, and also we need to change it into complex because we want to use the value of imaginary here. Okay, next is the central ordinates. For the central ordinates properties, okay, this one is in the table of properties. For example, for the central ordinates, we can calculate the value of n equals to 0 and k equals to 0, and also the half or the folding image of the signal for discrete signal and also DFT. In our question, the number of sample is 4. So 4 divided by 2 is 2. Therefore, we can find X2, discrete signal 2, and also XDFT 2, where the K is equal to 2. This is the central ordinates. The question asks you to find the value of X0 and XDFT0. So this is in the properties table. We just sum up the value of XDFTK from K equals to 0 until K equals to 3 and divide by 4. So the answer will be 1. And whereas for to find the XDFT0, we just sum up the discrete signal, all the discrete signal from 0 until 3, and the answer will be 4. Okay, the last question is regarding on the Parseval relation. So this is the equation. Also, this one is in the table of DFT properties. So the question asks you to prove the Parseval relation. So in the table of the properties, we have xn to the power of 2, the summation of n equals to 0 until 3 of the discrete signal, xn to the power of 2. So our discrete signal is 1, 2, 1, 0. 1 to the power of 1, we get 1. 2 to the power of 2, we get 4. 1 to the power of 1, we get 1. 0 to the power of 2, 0 to the power of 2, we will get 0. So the answer of the summation will be 6. And then for the XDFTK, this is the equation in the table, the properties. So our XDFTK is 4 to the power of 2 plus negative j 2 to the power of 2 plus 0 plus j 2 to the power of 2 and divide by 4. So negative j times negative j is negative 1. 2 times 2 is 4. And this is modulus, so the answer will be 4. And the same here, j2, because our value, we need to find the modulus value. Therefore, the value will always be positive. 16 plus 4 is 20, plus 4 is 24, divided by 4 is 6 joule. So this one have proof that the Parseval relation, because these two equations give the same answer. Okay, so please do the exercise 4.3 at home, so that we can check whether you understand or not the lecture for this week.